This lesson is on determining whether two lines are parallel or perpendicular. Before we really dig deep into this, let's look at these two equations. Let's graph them. Alright, let's look at this first one, y equals 3x. We know that the number in front of our x is our slope. So m is equal to 3 over 1. Alright, if it doesn't have a y-intercept, remember to always start your graph at 0, 0. So we're going to plot our first point at 0, 0. And then our slope tells us how many go up and over to our next point. So since the slope is 3 over 1, we're going to go up 3, 1, 2, 3, over 1. Alright, then we're going to follow that slope backwards to graph a point before the origin. So we're going to go down 3, 1, 2, 3, and to the left 1. Alright, so here's our line. And this is y equals 3x. Alright, now let me change colors here. And now let's graph y equals 3x plus 1. Alright, still our slope is 3 over 1. We're getting that from there. And this time we have a y-intercept as 1. So we're going to start graphing our line at the y-intercept. So we're going to plot a point at 0, 1. And then our slope tells us to go up 3 over 1. So starting at the y-intercept, we're going to go up 3, 1, 2, 3, over 1. And then we're going to follow that backwards. We're going to go down 3, 1, 2, 3, and then over 1. Alright, now, these lines are very, very close together. And because I'm doing this on my iPad, they're not quite straight. But as you can see, these lines are parallel. Parallel means that the lines are never going to touch. Think of railroad tracks when you think of parallel lines. Okay, so just like I said, parallel lines do not intersect. And what I didn't tell you on the last slide is that parallel lines have the same slope. So let's go back 1 second. Alright, our slope in both of these problems was 3 over 1. The lines never crossed one another. They had the same slope, therefore they were parallel. Let's take a look at these. Let's look at y equals x. Now remember, if you don't have a coefficient in front of your variable, that your slope is 1. Remember, if there's not a coefficient there, it's understood that a 1 is always there in front, and that goes with any variable. So for the top equation, my slope is 1 over 1. And then let's look at the bottom equation. What is my slope? Still 1 over 1. This time I do have a y-intercept, 0, negative 3. Alright, so let's go back to green. Let's graph the first line. There's no y-intercept, so we're going to start at the origin. Slope is 1, so we're going to go up 1 over 1. And then we can do the point before the origin, down 1, and to the left 1. And as you can tell, that's just going to go through diagonally. Alright, now the next line, y equals x minus 3. My y-intercept is 0, negative 3, so that's where, let me change to red. That's where I'm going to start my graph. And then up 1 over 1. And then the opposite way, down and left. Again, you can see that these lines are just going to run side by side. They are parallel. When two equations of a line have the same slope, those lines are parallel. Alright, let's take a look at these two equations. We can graph them very easily. Let's look at the first one, y equals 3x plus 2. My slope is 3 over 1. Comes right there in front of x. Remember, y equals mx plus b. And my intercept is 0, 2. So let's graph it. We're going to graph first the y-intercept, 0, 2. And then we're going to go up 1, 2, 3 over 1. And then down 3, 1, 2, 3 to the left 1. Alright, so here's my line. Alright, let's go to the next one. Let's change to brown this time. Alright, this time my slope is negative 1 over 3, and my intercept is 0, negative 3. Okay, so let's start at the y-intercept, 0, negative 3. And my slope tells me that I'm going to go down 1 over 3. And if I follow that the opposite way, I'm going to go up 1 and left 3. Alright, now, if my lines were a little straighter, you'd really be able to tell, but these lines intersect at a 90-degree angle, and that's exactly what perpendicular lines are. Perpendicular lines intersect at 90-degree angles. Alright, remember a 90-degree angle is a right angle, so right or 90 degrees. Those are the same thing. And there is also a relationship between the slopes of perpendicular lines. The product of slopes of perpendicular lines is equal to negative 1. And remember that product means multiply. So let's pull the equations from this last slide. So y equals 3x plus 2. And then y equals negative 1/3 x minus 3. Alright, let's take these slopes and let's multiply them just to see if this works. Alright, so we know that the slope of the first line is 3 over 1. Product means multiply. And we're going to multiply it by the slope of the other equation, so negative 1 over 3. Remember, when we multiply fractions, we multiply straight across. 3 times negative 1 is negative 3. 1 times 3 is 3. And 3 over 3 simplifies to negative 1. So as you can see, when the slopes are opposite reciprocals, that means you have one positive and one negative, and reciprocals of one another are flipped. So we had 3 and then we had 1 over 3. When the slopes are opposite reciprocals, their product is negative 1 and the lines are perpendicular. Let's take a look at some equations. Alright. Let's say we have y equals 2x plus 1 and y equals 2x minus 4. Alright, are these two lines parallel or perpendicular? Alright, they're parallel. We know that they are parallel because the slope is the same in each of the lines. Alright, let's take a look here. Y equals 4x minus 3 and y equals negative 1/4 x plus 2. Alright, are these lines parallel or perpendicular? If you said that these lines are perpendicular, you are correct. We know that they are perpendicular because the slopes are opposite reciprocals. We have 4 and we have negative 1/4. And if you wanted to check yourself, you could multiply 4 times negative 1/4. 4 times negative 1 is negative 4. And then remember that would be over 1. 1 times 4 is 4, which simplifies to negative 1. Just a quick review here. Remember that parallel lines have the same slope, and they are lines that never intersect. And perpendicular lines have slopes that are opposite reciprocals. Look at the example 2 and negative 1/2. And those lines intersect at right angles. Alright, your homework due at the beginning of our next class. I need an example of equations of parallel lines and an example of equations of perpendicular lines. You need to give me one pair of equations that are parallel and one pair of equations that are perpendicular. Alright, remember, if you have any questions, write them down so you can ask in class.